Traveling at 17,500 miles per hour, an astronaut watches the sun rise and set over the Earth 16 times in a single day. This environment is home to the International Space Station, a 445-ton laboratory floating in the sky that covers the footprint of an entire American football field. Between 1998 and 2011, it took over 136 separate space missions to build this structure. Astronauts ferried individual modules and solar panels into orbit and manually connected them piece by piece while floating in zero gravity. This process required over a decade of continuous manual labor. By the time final assembly was completed, the cost of opening the laboratory's doors reached roughly $150 billion. Beyond the construction, the daily operation of the station faces a severe economic hurdle. Shipping just one single liter of water from Earth to the ISS costs between $10,000 and $30,000 in fuel and cargo space. Since the year 2000, 6 to 7 people have lived aboard the station without a single break. Relying on constant physical rocket shipments to provide their daily drinking water and oxygen would be economically impossible. To maintain a permanent human presence 250 miles above Earth, the crew couldn't rely on a constant supply line. They had to operate within a completely self-sustaining, closed-loop ecosystem. This diagram shows NASA's water recovery system. It collects ambient humidity, astronaut sweat, and human urine. This waste funnels into a multi-stage filtration setup, passing through a high-temperature catalytic reactor to strip impurities, and is treated with UV light to destroy microbes. Continuous sensor checks ensure the final product is 100% pure. It's cleaner than tap water, allowing today's coffee to become tomorrow's lemonade. This system also provides the station's air supply. Through electrolysis, it splits recycled water apart, routing pure oxygen directly into the cabin. By mastering this incredible chemical loop, astronauts are now extracting breathable air directly from their own recycled waste. While the engineering is efficient, the physical reality of living in microgravity is disorienting. Everything from food to tools must be locked down with Velcro or magnets, and astronauts sleep strapped to the walls of private quarters the size of a phone booth. Without the constant pull of gravity, human muscles quickly atrophy. To prevent this, the crew is required to exercise for 2 hours every single day using specialized resistance equipment. Physical maintenance of the station is equally unpredictable. If a critical tool, like a specific ratcheting socket wrench, is missing or breaks, the crew cannot wait months for a resupply rocket to arrive. When Commander Butch Wilmore faced this situation, engineers on Earth beamed a digital CAD file straight to the station's server. Wilmore loaded the file into an onboard 3D printer and manufactured the required wrench in just 4 hours. Solving the tool problem transformed the ISS into an on-demand manufacturing facility, allowing the crew to create what they need when they need it. This effort leads to a central question: why invest $15 billion to keep this laboratory floating in the sky? Consider the cancer drug Keytruda. On Earth, the drug's original liquid form was so dense that patients had to sit through painful, hours-long intravenous hospital drips to receive their treatment. To improve it, scientists needed to study the drug's protein crystals, but Earth's gravity warps their growth. In the microgravity of the ISS, researchers watched these crystals expand perfectly in all directions. This experiment allowed scientists to reformulate the drug into a simple injection that takes only minutes, saving millions of cancer patients from hours of hospital discomfort. Other dividends are appearing in hospitals. The resistance equipment built to fight astronaut muscle atrophy is now being used to treat osteoporosis patients on Earth. The station also serves as an orbital lookout. From 250 miles up, it tracks hurricanes, floods, and wildfires, sending rapid alerts to emergency responders on the ground. Although the station is scheduled for decommissioning in 2030, its legacy persists in modern aviation technology, advanced MRI machines, and high-speed internet. The International Space Station was an engineering challenge that demanded solutions for survival in a vacuum, solutions that now drive innovations for the world below.